Hey folks, in this video we're just going to be looking at how to find area of something called composite figures. Now previously we've covered how to just find area and perimeter or circumference of just our regular polygons and circles. And you'll notice here on this page that it kind of looks like the shapes are kind of being mashed together. So what we're going to be looking at is these things called composite figures. And the way we're going to find the area is basically we're going to find areas of certain shapes and just add them up. And you can see here for the first two that I actually have the two shapes very clearly kind of separated so that you can see, for example, here we've got a trapezoid and then a rectangle. But eventually the shapes kind of look like this, where there's not necessarily anything on the inside breaking it up into the different shapes. So we're going to start with these first two up here, and then I'm going to show you guys some examples of how you might break the shapes up on your own and then find the area. Okay. Now off to the side, these are all the formulas from the formula sheet that I went through in the last video. And I'm actually going to get rid of the two circumference ones in the perimeter because we're not going to care about the outside today. We're only going to focus on the area, which is the inside. So first thing I'm going to do is get rid of those formulas. And friendly reminder that you do have a formula sheet. It was the last page in your packet. And so some of you just decided to keep it stapled in your packet. Some of you have ripped it off and you're kind of looking at it side by side. Totally up to you. All right, so for this first shape right here, what we have is it looks like we've got a rectangle, and then it looks like there's a trapezoid kind of sitting on top of that rectangle. So basically for the area of the rectangle, we know that it's base times height. And then for the trapezoid, that's this last one right here. And again, we covered these formulas in our last video. All right, let me turn the cloner on for these. Okay, perfect. So for this first one right here, if we're doing base times height, it's just a 24 by 13. And I'm going to use the calculator here so you guys can just look here. We've got a 24 by 13. So that's going to be a 312. That's a 312 right here. So this part's 312. All right, now up here, this is a trapezoid. So let's review real quick how we find the area of the trapezoid. We just take half the height, and the height here is the distance from this base to this base. So we got a 13. All right. Now you might remember that the B1 and B2 here are the parallel sides. So we have this line and this line, which are parallel to each other. This bottom part is a 24, and then the top part labeled as a 13. So we've got a 24 plus a 13 here. You can use Desmos if you want, and then plug in that formula. Remember, for Desmos, you can use an H, you could use a B here, and then you might just need to use an X for this other one, just because in Desmos, there's no way to put those little subscripts. Or you can just use your calculator here. I'm just going to do the 24 plus 13. I'm going to add up my bases. And then I'm going to multiply by the height, so times the 13. And then I'm just going to take half of that by dividing by 2. So here we're going to get a 240.5. This part up here, this area, is 240.5. So all we need to do now is simply add these two areas together. I have the 240.5 left in my calculator, so I'm just going to add the 312 for this rectangle area. And it looks like our total area here is going to be 552.5 square inches. 552.5 square inches. When you write it, you're writing inches squared, but when we say square inches. All right. So we just took a rectangle and added the area of the trapezoid, and we found the total area. All right, cool. Now let's take a look at this green figure here. So in this green figure, I see a trapezoid right here. We got a trapezoid, and next to it is actually a semicircle. We got a half a circle. Friendly reminder from our previous video that this trapezoid over here, this is called the isosceles trapezoid, just because those two sides are the same, kind of like in your isosceles triangle. And then over here, this was called the right trapezoid because we had right angles here and here. So we're going to be finding the area of a trapezoid, so we know we need this formula. And then the circle, we certainly need to find the area of a circle as well. The only catch is, since it's half the circle, we're going to take that area and we're just going to do divide by 2. Okay, that's the only catch there. All right, so let's start to fill in for the trapezoid here. We're gonna, whoops, let me get my red pen, here we go. We're gonna do half the height. So the height of this trapezoid from parallel line to parallel line, that's this 4. It's actually the diameter of our circle labels the height of the trapezoid. All right, so we've got a 4. And then the parallel line here is a 7, and this parallel line here is a 3. So we've got a 7 plus a 3. 7 plus 3 is 10. You guys know that. That's super simple. And you guys know that half of 4 is 2. So the trapezoid, we can just go ahead and get real quick without a calculator. That's going to be a 20. So we've got 20 square meters here for the trapezoid. Now let's take care of this semicircle. So for pi, we use 3.14. The radius is half of what we're looking at here. So if this whole diameter is a 4, the radius right there is a 2. So we've got a 2 here that we're going to plug in for the radius, and then that's going to get squared. And when we do 2 squared times 3.14, that's going to be the area of a circle, and we'll just divide that whole answer by 2, because again, it's half a circle. All right, so in our calculator, I'm just going to do 2 squared, which is 4. So I've got 4 times my 3.14. And so that would be the full circle, but now I'm just going to cut it in half, and 6.28 would be the semicircle. So if this is a 6.28 and this is 20, I just basically need to add them up, and we're going to get a 26.28 for the total area here. 26.28, and that's square meters. Okay. So we've got these first two done. And again, what they had in common was that there were kind of lines on the interior of the figure, kind of breaking it up so we could see the trapezoid and the semicircle, or the trapezoid and the rectangle. Now, for this third shape here, of course, there's no line drawn on the interior, but I feel like you guys can kind of see it. Let me get my dotted line tool here. If I wanted to break this up into 2 shapes, I'm not necessarily going to do this, which makes it look like an igloo, because there's nothing here for me to find the area. There's no formula for this weird thingy here. So we don't want to split it up that way. But if I split it up like this, now I've got a rectangle, and on top of that rectangle, I have a semicircle. So for this one, we just need let me pull my 2 formulas here. We're going to need base times height, or length times width, however you want to think of it for this one. And then again, for this semicircle, we've got pi r squared, but friendly reminder that we just need to cut it in half. Okay. So for the length times width, this one's going to be pretty simple. We've got a 9.2 times 1.5. So we'll just use the calculator. 9.2 times 1.5. And that's a 13.8. So I'm going to jot that down so I don't forget about that. That's a 13.8. That's the rectangle there. And now let's take care of this semicircle. Okay. So the semicircle, we know pi is 3.14. We're going to need the radius squared, and we're going to have to cut that answer in half. So let's come over here and take a look at our circle. And let's see if we can figure out what this radius is. We need the radius. So I care about from here to here. Now, if we look carefully, we can see that this part is labeled, this is a 2.5. Okay, this is a 2.5. And this entire purple bottom is 9.2. Now I can see that this much of it is 2.5. The radius is what I'm trying to figure out next. So if I do this 9.2 minus this 2.5, it'll give us this chunk right here. So let's go ahead and do that real quick. We're going to do the 9.2, and then we're going to minus 2.5. So what we're saying, y'all, is that this whole thing is a 6.7. Let me put that in green. This whole thing was a 6.7. Again, that's this thing right here. That was the 6.7. And I know that that's 6.7 plus this 2.5. That's where I get my entire bottom, the 9.2. So this 6.7, that's our diameter. I found the distance across this circle. So we're going to go back to our calculator now and just cut it in half, and we finally found our radius. So the radius is a 3.35. It looks like I'm going to need a little more room here. 3.35. All right. So friendly reminder, all I just want to make sure I didn't lose you real quick with that part right there. We just said that the entire bottom is 9.2. This much of it is 2.5. So this has to be a 6.7. And half of that, the radius, was my 3.35. We are finally ready now to crunch the numbers and get the area of this semicircle. So let's bust out our calculator. We've got a 3.35. I'm just going to do times 3.35. That's going to be the radius squared. Now we're going to do times 3.14. Now I'm just going to cut that in half because it's a semicircle. We're going to round this to the nearest tenth. So I'm going to use this 1. Since it's lower than 5, I don't need to change anything here. This is going to be a 17.6. So my semicircle is a 17.6. So if this is 17.6 and this was 13.8, all we need to do now is simply add them up. All right, so I got my 17.6 plus 13.8, and the total area there is 31.4 square centimeters. 31.4 square centimeters. If there are multiple choice questions here in this unit, some of the answer choices you might see, for example, if you did the math and got the semicircle, the 17.6, you might actually see that listed as an answer choice, because sometimes when we have all this math going on and all these steps, we might forget, oh yeah, I got to take this and now add it in. You might also see, if this thing wasn't cut in half, that 17.6, I forget, it was like a 6-1 something. I'm just going to double that back real quick. So the full circle would have been a 35.22. And again, you just might see these as answer choices because sometimes just along the way, when you see an answer that you get over here, you might pick it and forget that there was more to do. But neither one of these would be the right answer because, of course, we need to take the 17.6 and add it to the 13.8, and that's the total area. All right, just a couple more. I'm going to move to a new page here, but these are still the bottom two. These are the bottom two on your page. I was just running out of room on the other one. And I don't need these formulas, like I said. And let me make sure I have the cloner turned on for these so I can just click and drag. There we go. All right, now real quick, what I want you to do is I actually want you to pause the video and I want you to try to break this shape up into 2 parts. And I want you to actually try it both ways. It doesn't matter which way you put where, but I want you to just pause the video real quick and draw one line. And using that one line, you should break it up into 2 parts. And when you hit play, we'll keep going. All right, so the lines we should have, one possible line would be here, and one possible line would be right here, okay? So it doesn't matter to me which way you as a student sees this. If we break it up this way, we've basically just got a triangle on top of a rectangle. And because students are really comfortable with the area of a triangle and area of a rectangle, I feel like this might end up being a more popular way. If we do it this way, see how we get a trapezoid here? And sure, we have a formula for a trapezoid, but because this is the longer formula and it's kind of weird and new, not a lot of students want to go this route and find the trapezoid. But if you see it split up like that, it doesn't matter. And in fact, I'm going to show the math for both of them real quick, and you're going to see that we actually get the same answer. So if we break it up this way, we needed the area of a triangle, and then we simply had just a rectangle, and we were just going to add these up. If we break it up this way, it would have been a trapezoid plus then a rectangle. Okay, so again, it doesn't matter how we see it, but when we do it both ways, we should get the same answer. All right, so for the triangle over here, I need my base and my height. So if I look carefully, again, the bottom here is a 12 and this is an 8. So if 8 of it's figured out, we know this has to be a 4 because 8 plus 4 is my 12. So this base here is a 4. And now let's real quick find the height. All right, so here we have a 4, which means this much must be 4. So this has to be a 6. Okay, because 6 plus this 4 would give me that 10. So we know for the triangle, we're going to basically just do a half of a 4 by 6. Y'all know that 4 by 6 is 24, and half of that is 12. All right, now the rectangle, very simple. We've just got 12 by 4, which is 48, so we're going to add 48 to that. And right here, we're going to get a straight up 60, and that'd be 60 square feet. And like I said, this way might end up being more popular simply because triangles and rectangles are just more familiar for us. Now, if we look over here at the trapezoid situation, so the trapezoid, if we need this height right here, it's the same as this dotted line right here. That's the same. So we know that this is a 4. We already figured it out in the last problem. So we've got a 4 for our height. One parallel side is a 10. The other parallel side here, this dotted line, is this 4. So again, 10 and 4 because of that 4. And then this 4 we already figured out because we know 4 plus 8 gives me this bottom 12. So the trapezoid part over here, we've got half of 4 is 2, and then this is a 14. And y'all know 2 times 14 is 28. We don't need a calculator for that. And then we're just basically going to add the area of this rectangle. And this rectangle right here, 8 by 4 is a 32. So we're just going to add 32. 28 plus 32 is also 60 square feet. So it doesn't matter how you choose to break it up. You see that we'll get the same answer. And now if you guys will flip over, you'll see these two problems. And let me pull these two real quick. Let me just cut and paste. Sorry about this. You should see 4 problems on the next page. And here's the other 2. And your goal is to find the area. You can see that some of them are already kind of split up. Some of them are not. There's no wrong way to break this up. As long as you find the area of all the parts, you can just add them up. Same thing over here. Now for these two, I see that there's some lines in here to kind of help you see. For example, if I'm trying to find the total area here, I've basically got this and this makes a full circle. I've got a triangle and I've got a semicircle. Same thing here, I got a semicircle. And I think for you guys, you should see here on your notes that there's lines there. So that's a 6 by 6 square. And for the sake of the math in the calculator, anytime you see a fraction labeling a dimension, definitely just make it a decimal. And that's not a problem. So you've got some practice here on this page, and there is going to be a Google form for your answers. And then there's some more problems too after that. Again, they're just split up on my screen here. But the next couple of pages here, you guys are going to find the total area of these composite figures. And that concludes this video. Thank you for watching.